So the terminology extreme values, makes me feel like this should be like chugging Mountain Dew or some energy drinks or something. It's
Education is priceless.
kind of silly. It's kind of, well, extreme, but it does fit what we're talking about here, that with these values, what we're identifying are locations where the function is bigger or smaller than the things around it. Things like peaks and valleys, where in particular, we say that f of a is called a relative maximum for the function f if you have an open interval such that f of a is bigger than f of x for all x in that open interval. And again, not super obvious, but we'll see what that looks like with a picture. First, I want to be clear about what a relative minimum is as well, which has basically the same definition, f of a, such that f of a is less than x, for f of x, for x on that open interval other than a. You know, we're careful with that notation, we're careful with being very specific there, but just see the picture and you can understand that a relative maximum is like a bump on top. It's where we're getting to the top value, the maximum value, and the relative minimum is like a valley at the bottom. That's the smallest value in a neighborhood. And there's something else you can talk about that you'll probably see later if you go on further with math, a thing called the extreme value theorem that says you are guaranteed to have an absolute maximum and minimum on a closed interval for a continuous function. We're not going to look at that too much. In this class, it's just worth mentioning that you do have other nice properties that we can talk about here, but for now, we're just going to be looking at how we specifically classify those bump values, as it were, in terms of what are called extrema, in terms of extreme values, where, with this definition in mind, we can reclassify what we were talking about earlier in that last example, those points -1 and 1, where at -1, that function is a little bit bigger than all the stuff around it. It's got that bump. That's what we call a relative maximum. And +1, it's that peak, or excuse me, that valley. Get those words right. Math, we got to be specific, right? That's at the bottom of the valley. So that's what we call a relative minimum. It's the sort of thing that, again, it's a lot easier to see and describe loosely than to very specifically give mathematical notation. But to be sure, we are rigorously defining these things here. That's much of the purpose of what we're looking at, where we can see in this case as well that in terms of how that function is pictured, it almost looks like if you took some careful deformations around there, that you could rearrange it and end up with the same thing on either side of the origin. And that's a special idea that you've probably seen a lot of in the context of geometry called symmetry. And in particular for functions, there are some very specific ways we can look to identify symmetry in their behavior, and that's what we'll be describing next.